So how we define our uh, MDE? MDE means managing development tools, basically managing development environment. Okay, so we have a GitHub. GitHub is a place where we can store source code only. It can be application source code, it can be infrastructure source code. Application source code means Node.js, Java, .NET, Python, C Sharp, and you name it, any application source code like a front end, all that kind of application source code. And infrastructure as a code, that means Ansible playbooks, cloud formation stacks, Terraform, and shell script, bash script, you name it, Python script. You can store any of your source code in GitHub. What we do here, we create branches. Okay, we try to migrate that code to production ready in a better way, right? If I write something and if I can say like, hey, this is working fine, can you go ahead and migrate this code to production, which is not going to work, right? It doesn't work that way. It doesn't mean we don't trust you. Companies should have some standards that they can go through. So some of our team people, they can review it, they can approve it, and they will migrate the code. We will migrate the code. If somebody from our team implement something, it has to go through the same way. I would have to review it, I would have to approve it, and I would have to migrate the code to the production, right? And this is GitHub. This is the place what we do. Now our source code is ready. Now our application source code is ready to serve, ready to be an application, right? Now, in order to make this application source code live means end user can access this application, we would need infrastructure. This is infrastructure. It can be on-prem physical servers, on-prem data center, or any cloud. In this scenario, our cloud is AWS, right? Now I have multiple options. I can build this source code as a Maven package. And I can deploy that source code into this infrastructure. Or I can build the source code as a Docker container. And I can deploy the source code into my infrastructure. If I build a Maven package, I can store this Maven package just in case. Let's say I have this package, this star file or jar file or war file or yar file, right? Packaged version of my source code. Just in case I want to keep a copy of the jar or tar war file, whatever the file. So I can store these artifacts. This jar tar war file can be called artifacts. I can store this artifact any of these places. Maybe Nexus. Nexus is a similar server like a GitHub, but in this case, we store only artifacts, not entire application source code. Or you can store them in S3, or you can even store them in ECR, Elastic Container Registry. It's the same way. You can store your Docker images into Nexus, or you can store them your S3 into S3, or you can even store them into ECR, Elastic Container Registry. And you can deploy. Store in the sense you have a copy of it, and you're deploying a copy from here to AWS infrastructure. Okay. So now your AWS infrastructure means you have a plenty of services that you can use. One of those services is EC2. This is the place where you are actually allocating memory for your compute resources. Let's say your Docker container, your Docker image become a container here. Your Maven artifact become a application here. This is the place where you can install all your necessary. If I use Docker, what should I install? I should install only Docker on this machine. If I use Maven package, I should have a Java installed and I should have a Maven installed in order to install that Maven packages, and I should have a plenty of prerequisites installed in this machine. Right? Basically, this is the computer. Okay, and this is the data center. You can call it as a cloud data center, which is provided by AWS. Are we clear here? Any doubts till now? Okay, let's move forward to once. So we discussed about this Maven and we installed our first Maven application already. We build Maven artifacts, we installed them on EC2 machine and we verified them. We clear that. Let's talk about Docker. So we did even build a Docker image yesterday, right? And we did even build we wrote Docker file, we built Docker image, and we discussed about like commands in Docker file, and we discussed about layers in Docker, right? Now let's discuss about what exactly, who manages those Docker containers basically. Let's discuss about them actually. So now I have a multiple containers, right? Let's say I have a 10 microservices. Each microservice built as a container, Docker container. Example, I'm talking about example. So each microservice running as a Docker container. This is a Docker container, Docker container, Docker container, Docker container, and Docker container, right? Now I have example, for example, four EC2 instances, right? Now I want to use these four EC2 instances to deploy these 10 microservices. Okay, to deploy these 10 microservices. Now I have challenge. I have a very limited resources that I want to use, that I can use, and I want to provide accommodation for these 10 microservices. Okay, they're being packaged individually. Like this is written in Python. Example, this is written in Java, and this is written in Node.js, right? And this is written in Java, and this is written in another architecture of Python, maybe Scala, Kafka, that kind of Python, whatever, right? They're being built separate packages. Now I need a person who can manage them, who can orchestrate them. Let's say, for example, if one of these containers running on the EC2 instance stopped accidentally, let's put it different way, not accidentally. Let's say this running container allocated, for example, 2 MB RAM, 2 MB RAM, right? And same time, like per second, it has a request for 4 MB RAM. Let's say we anticipate, like we expect 100 people to use this container at a time, but unfortunately a lot of people trying to access that system, and we have 200 people trying to access that system at a second, and the container stopped working. The same way, we try to access that EC2, but EC2 doesn't have any memory, right? And we couldn't able to access it. The same way, the container stopped. But the container is not going to restart itself. This is the magic thing. The container, the Docker container, does not have the capability to come back after that request, after this 100 request, this 200 requests per second, and next second they will still receive only 100. But the container is not even ready for that 100 because the container is stopped, right? And you would have to log in there and you would have to identify the root cause, but you're not there. You are somewhere in Europe, for example, and or this is half hour, night 12 o'clock, right? And none of the resources, they don't want to sit in front of computer and monitor 24/7. They do if something goes wrong, but no, right? We need a person who can manage these containers, who can manage, who can orchestrate these containers. That guy is Kubernetes. Kubernetes. So how does that Kubernetes works? Kubernetes divides, Kubernetes components are two parts. One part is admin, master, let's put that way, master and a worker nodes. Okay. So we would have to install kubadmin on these machines, and we would have to configure them with a kubadmin. We would have to configure each worker with a kubadmin. So the kubadmin will monitor all the resources in these 4 instances. These 4 instances can be grouped as a cluster. Okay. So the kubadmin, the master, keeps sending requests to each container on these machines, basically on these 4 EC2 instances, and it will expect a response back. If that Kubernetes master will get a response, that means the container is active, it's up and running. If that does not get any request back, any response back, it will decide that, okay, this container is stopped at the moment on the service, on the server, and what it will do, whatever the request going for that container on the specific node will be transferred to a different container, same container on a different node. Is that make sense?
So it maintains only containers, like it monitors, or if something goes down, or it will.
Yes, that is the Kubernetes guy. Yeah, Kubernetes is a container orchestration basically.
Okay.
Yes.
Same image transfer chestada Vishnu.
What was that actually?
అంటే మనకు కావాల్సింది సేమ్ ఇమేజ్ ఉంటది ఫార్వర్డ్ చేస్తుందా?
No. It's not forward any images basically. What it doesn't have to do with any images basically. So image is out of scope. Image is behind the picture basically. Image is, you will have images before this environment. You are not in infrastructure yet. You are building behind your infrastructure. Okay, this is your infrastructure, let's put it that way. Okay, your image is ready before you get to your infrastructure. This is the image part. Okay, after GitHub part, this is your GitHub part, then you have image. Okay, this is the place you built your image, and this is done. Now you build containers from this image and you deploy those containers here in Kubernetes. Now it is Kubernetes responsibility to manage them basically. Does that make sense?
Okay, Vishnu.
Okay, na? Any questions till now?
So when we have multiple containers, then only this Kubernetes will maintain, or if what happens if we have only one container? Then also do we need Kubernetes?
Yeah, let's say if your container is running on an EC2, right? For example,
Yeah,
for any reasons, your Docker stopped, your Docker is not running,
right,
and you would have to restart the Docker for some reasons actually. So the Docker is not going to restart itself basically.
right, okay,
You need a guy like a guard, like a watchman
right,
to monitor your Docker container. It's possible you can run your Docker container on your EC2. You don't need any Kubernetes, right? For something goes wrong, why not? Let's configure this guy, and this guy is going to help us. And you can even scale. Let's say you deploy 2 replicas, right? For each container, you deploy 2 replicas, for example. Okay. You are expecting a lot more than what you thought. And you need a 10 replicas, for example. All you have to do, just replace this 2 with a 10. That's it. And this Kubernetes guy will take care of the rest.
okay,
He will build 10 replicas for you. All you have to tell him what container should have a 10 replicas. That's it. And I'll show you in a minute actually how simple is that. Okay. Are we clear till now?
So Vishnu, we will install the master node on cluster and worker node